Okay, so we've got two ways that we can measure angles, right? We're very familiar with degrees, and the best way to think about degrees, right, is it's a pizza and you cut a pizza into 360 pieces, right? So if we cut it into 4 pieces, then each of these would be 90 degrees. And all that means is 1 degree is 1 out of 360th of a rotation. Now this measure is what we call arbitrary, in that we've divided it into 360 parts, but we could divide it into any number. You could divide it into 1,000. The reason we've used 360, that's come to us from the Babylonians. 360 is divisible by every number from 1 to 10 except 7. So it's a useful number for dividing up a circle. Alright, so that's why we've chosen 360 and that's why it sticks around. It could be different. We're going to look at one that's not arbitrary, that's sort of a measure of angle that exists in the nature of a circle. And these are called radians. And like its name suggests, it comes from the radius of a circle. So if you think, if we have some circle here that has a radius, that's some distance, then 1 radian is the measure of that radius on the outside of the circle there. That would give us an angle of 1 radian. And the way we would say a radian, the notation we use is a C. Of course, intuitively, lowercase c represents radians. So that means you can imagine 2 radians being around here. All right. That would be 2 radians. All right. Now, in a half a revolution, we have pi radians. Pi is 3.14. And in a full rotation, we have 2 pi. All right, which is 6.28. Okay, so we have these other ways of measuring angles. Now, the way we're going to convert between them is that if we move from degrees to radians, we just multiply by pi on 180. And if we're moving from radians to degrees, we multiply by 180 on pi. So here in our first question, we're asked to convert from, firstly, degrees to radians. So what we'll do is we'll start here. We're moving from degrees to radians. We have to multiply by pi on 180. Now, if you type this into your calculator, it'll just pop out as something like this, right? It's going to pop out a number in terms of pi. Now, this is an exact value. Now, let's familiarise ourselves with rounding it as well. We can press the surd to decimal button. And if I do that, I get 1.308. Okay, 4 figures. We round the 4th figure, 8 rounds up, which takes us to 1.31. And we need our unit there, which is C. Okay, we'll do 31 degrees. If we multiply it by pi on 180, our calculator might just pop this out, 31 pi on 180. And if we evaluate that to 3 significant figures, we'll get 0.5410, which is 0.541. C. Okay. 145 degrees. Okay, so again, we're moving from degrees to radians, so we're just typing this part in our calculator. Multiply it by pi on 180. So we have 145 pi on 180. It'll simplify down to, this simplifies to 29 on 36 pi. So we can express it like that, or if we convert it to 3 significant figures, we'll have 2.530, which is 2.53. Okay, so they're all the degrees to radians conversions. Next, let's look at converting from radians back to degrees. So this time we're multiplying by the reciprocal. We're multiplying by 180 on pi. So 3 pi on 2 times 180 on pi. Now we could simplify this manually, right? I'm looking at this fraction operation going, okay, so what we do is pi at the top, pi at the bottom, that'll cancel. 180 divided by 2, that can simplify to 90. 3 times 90, that's 270. But you can type it, if you just type that in your calculator, it will pop out as 270 degrees. Okay, pi on 6, we multiply by 180 on pi. This is going to be a common one for you. This will be 30 degrees. This one you can see pi at the top, pi at the bottom cancels. 180 divided by 6 is 30 degrees. And then 2 radians, if we convert 2 times 180 divided by pi, we'll get 114.5, which is 115 degrees. Okay, so that's enough to get us started on the radian measure. I would anticipate today us doing 5A after recess, 5B, but that's certainly enough to get started on 5A.